afternoon or good evening or even perhaps good morning if you're in the US. Um, this afternoon or whichever part of the day you're in, I will be talking about Fluentd, one of the projects coming out of the CNCF initiative. Let's quickly get on and I'll talk you through the background and the context and talk a little bit about monitoring and monitoring techniques. So me in 5, husband, father, blogger, author, written a couple of books. If you want to pick up and follow up anything, then the best bet is just take a note of that address. Yes, it's a bit of an odd one for a technologist, but there is a very long story behind it. Aside from that, I run a meetup and I've written articles on books. And perhaps the most relevant one is this one, which I'm working on right at this moment. And the first few chapters are available. Please feel free, if you find this interesting, to pick up and look at that content. And let's go. And incidentally, you'll probably notice when I go into a little demo, some of the stuff is actually in the book. I happen to be a senior consultant and tech evangelist for Capgemini UK. I won't say any more other than the fact we've got an award-winning team here in the UK, and that's more about Cap. So one of the keys really here is to let's perhaps understand the different aspects of monitoring and log analytics and observability, which is quite a trendy term that's coming in. And these 2 points, monitoring and observability, if you noticed, Maria in the previous session mentioned in passing, so it's quite appropriate. But fundamentally, what we need to be able to do is to understand what's going on in our environment, and we can look at it from a number of different dimensions. We can look at and collect metrics about our environment, so that's numeric-based data typically, things like your CPU utilization, your memory use, disk capacity, things like that. Then we have textual logs, which are almost the opposite end of the spectrum, which are describing what's going on, recording events. That could be things like your web server recording hits on web pages. That could be the OS recording issues or interactions in the OS layer, such as SNMP traps. And then, of course, you've got your application tracing. That's how you're going to track, particularly in a highly distributed solution space, solutions from the first point of contact to satisfying the result of an interaction request. So very different measures. Traces are a little bit of metric, numerical data, IDs, and a little bit of text, normally just to identify a location or a stage in the process. We can lay this onto our solution. So if we look at the host and the infrastructure and the monitoring and more modern solutions, particularly if you're in the cloud, you won't see that, and you'll be thinking about containers or virtualization. And you can see that a lot of the data is going to be metrics based. You know, when I mentioned the measures on the OS performance and so on. And your virtualization, you're going to be monitoring how efficient those containers are and how much density you've got and how hard they're working and things like that. But also you're going to be getting some logs both from the OS and from your Kubernetes or VMware or other virtualization layer. Recording any issues. They may also be creating audit trails about who's signing in or who's failed to sign into environments, requests that are being made. You know, if you're issuing Linux commands and things like that, that all gets audit trailed. And then, of course, the area that most people think about for monitoring is applications, where we got a nice blend of all three. We're going to be measuring how our application works. You know, taking measures from the VM, the JVM, or execution from the OS to say it's using so much resource and things like that, through to application logs, which is probably where we tend to look and think about monitoring the most. And then, of course, with more contemporary applications, tracing. And then right at the top of the stack, particularly in enterprise, ERP and things like that, you will start to think about perhaps business application monitoring, or BAM as it used to be known. Whilst it's not used so much or talked about so much these days, some of the BAM ideas do manifest in tracing, but not necessarily so aligned to the business side of things, but more about understanding how your each individual process or request is performing, and therefore being able to understand where your bottlenecks might be. And of course, then we've got the classic NFRs of security and feeding data into the security event frameworks, so that the audit trail of who signed on, who failed to sign on, when people have attempted to sign on and things like that. And of course, just making sure that you've got the capacity to run the solution that you're committed to. But the application of logs is quite an interesting one. Whilst we tend to look at things from the viewpoint of our role, it's got quite a diverse use case. Things like just spotting errors. These are the ops team are normally just wanting to know when an error occurs. They don't care about the application performance, you know, and not overly worried about slow SQL queries, whereas a developer you may well be, because you've got to hit some performance requirements. From a security perspective, the security team are going to be interested in who signed in, what, where, when, how. And then, of course, you're potentially needing to look at it from an end-to-end picture across all the various components that you're running. After all, how many applications are single executable binaries? At the very least, you're likely to have a database and an app server. And of course, at the end of the day, all of this comes down to how are we doing in terms of making our application and our business proposition work. How effective is it? Are we achieving our goals? So Fluentd came about quite a long time ago, actually. It was originally being built by a company called Treasure Data. And they were looking at big data use cases and wanted to try and harvest semi-structured data into a big data solution, but to an extent we're a little bit agnostic about what that solution was. So they started to develop Fluentd and its baby brother Fluentbit, and when they progressed it, it became open source and then was seeded to CNCF. And as a result, it's pretty agnostic in terms of the number of different things it can connect to, and that's led to a lot of people adopting it because it's not bound to any one vendor. So you've got a huge catalogue of inputs for log events, from TCP to Unix sockets to classic HTTP, and then just about every app developer will probably want to do basic log file connections, through to outputting with modern microservice technologies like Grafana and Prometheus, or even just into Dirty Great Big Database or Elasticsearch to do search and querying on your log events, and trying to use it to create sequence and ordering sense out of events, particularly if you're working in a reactive world where you're going to have Node doing a lot of context switching rather than threading up executions. And then all the way around that, you need to be able to store data, filter it, format it, pass it around the network, and so on. So the Fluentd ecosystem, which is designed to be highly pluggable and extensible, gives you a really rich capability. Another way to look at it is to consider what we're doing. I mean, ultimately, we need to make logs actionable. That's really what monitoring is all about. And if you've been working with integration, you'll recognize this pipeline. It's almost like an ESB in many respects. And Fluentd works beautifully well on source capture, structure, and route it. It can do some aggregation and a bit of analysis, but that's not its sweet spot. It tends to look to other products to do that. And this is why sometimes you'll hear about EFK rather than ELK, because people have swapped Logstash for Fluentd. But then obviously you go into the other end of the spectrum and you want to be able to analyze, push key events, critical events out to notifications quickly and so on. And we'll see that in a moment. So let me just give you a little sense of what the configuration looks like. We'll look a little bit more closely in a moment when I run the demo, but that's the sort of thing that we see when we set up configuration. It looks a little bit like a blend of XML and YAML. So let me talk to you about the demo first before we actually jump in and look at the actual assets and fire it up. It's a bit simplistic, but it is vaguely plausible in terms of how we might want to run in the real world. I have two files called basic file and basic file 2. They happen to be outputs from applications using rolling logs. One needs to be transformed and another doesn't, and we're going to pump out one of the sources into another file, which could be, of course, filtered and merged with other sources, but I haven't done that for simplicity in this case, but it illustrates the point. That, of course, could be in a solution that we need to scale. So we have multiple instances and we'll then potentially wrap that up, have a Fluentd node running on each server, perhaps. And this could be a microservice container, or it could be a classic traditional virtualization or even bare metal deployment, where we want to put a Fluentd node in each server and treat it as normal infrastructure. So we'll have multiple servers running, generating this content, as you can see. And then we're going to have at the other end of the spectrum a means by which we want to filter out specific messages that have significant meaning and send it to the console, or in this case, actually also leverage a notification mechanism. So if we see an error, then and it's an important error, let's say it's an error we've identified as indicative of the whole solution crashing in the next few minutes if something isn't done quickly, you want to send it to a notification channel where people can react quickly to the information, not send it to a database and wait until someone's done some analytics. So we're going to use Slack to demonstrate that kind of idea. And that would be on its own server, and you'd want to consolidate all of that. So we have to obviously do networking from our cluster of nodes, doing the hard work, to our single instance that would be dealing with the filtration of the events to determine which ones are important and which are not. In the real world, we're going to look at some significant challenges. I've talked about the highly distributed, we've mentioned the challenges of reactive, because reactive will park an execution and switch to the next one rather than holding a thread and wait for another end system. We have to deal with the fact that in larger organizations, we quite often see the situation where teams are split up based on their function. So some teams will want to use OEM. If you've got an Oracle database backend, then there's a chance you'll be asked to support Enterprise Manager for monitoring the database. The infrastructure team might prefer Nagios because it integrates far better into Linux to look at the details of each node. And then, of course, security teams might want to use a different tool because it's able to help tease out more effectively security-related events. That creates a bit of a nightmare, but trying to force an organization like that into using one tool is pretty difficult. So actually what we can do is use something like Fluentd to say, right, we'll aggregate all of the events and then we'll send off the right events to the right places. Yeah. And then obviously we want to identify more important events and perhaps treat those slightly differently to the run-of-the-mill events, which might say, you know, everything is hunky-dory. I've just done 100 queries in the last 30 seconds. So let me take you in and show you the demo. So let me drop out of my presentation, and you'll see in a minute a bunch of consoles, but let me just show you the configuration again. So I talked about the node 1. You can see here very simply I've created a source. I happen to have put into the same configuration, the same Fluentd instance is going to be looking at a different source. So I can monitor within a single Fluentd process. I can look at many different data sources or you know, monitoring events, if you like, using multiple plugins, which is how Fluentd is extensible. That gets passed into a pipeline, and I can do things like manipulate the event and the event structure. And then I can do things like, well, if it's a particular file or source, I can copy the data to a file using a buffering mechanism, so that because I'm using physical I/O here, I want to optimize obviously my write speeds so I don't slow things down too much. So I can tailor that with an in-memory buffering mechanism, or I can actually resort to using something like Redis as a larger cache. And then we push this out. You can see I'm talking to another Fluentd. It happens to be on a different port on the same machine, which is what this configuration is all about. And this then filters on one particular attribute and is looking for the words computer, missing the C for computer there because it might be an uppercase or a lowercase, and that's good enough for a match. And then I'll push that to the standard out for that node, and also shouldn't really show you this, but Fluentd, Slack, and this is how I connect to Slack using yet another plugin for Fluentd. I then have 2 little apps running, or one app running twice, that's being told to structure its content slightly differently. You can see the values here in different orders, and this will create my log events to track. And as you can see, the structure will be slightly different in both cases. And one instance will be verbose, so we'll see it chatting away as it generates logs as well, and the other one won't be. Right, so if I get all my instances up and running, so this is my first simulator, so it's going to start generating logs in a moment, and here is my second one. As you can see, it's starting to chat away, generating events. I'm now going to fire up my Fluentd. That's the first node, and you can see it's just logged out to the console the configuration, which tells me that everything is fine. And now I'm going to fire up my second instance. Whilst that's kicking off, I'm quickly going to bring my Slack client over. And what you'll see here now is these two working together. You can see it going out to console, reporting some of the log events. And now, if you're watching carefully, my Slack is spitting out messages, and you'll note it's telling me, because of the way I've configured it, what the origin of the message was. But it's not sending everyone, it's filtering out. So only comments about computers or on computers are being pushed to Slack. But you can see it's working there. And over here, you can see the log events being generated. So, bit Mickey Mouse, but it gives you a sense of the art of the possible, hopefully. And as you'll have seen, hopefully you'll realize that, oh, there we go, because I've taken my focus away. It's now telling me about the messages. You can see this is pretty straightforward in terms of configuring the setup. All right. And internally within Fluentd, it treats the payloads as JSON structures. So you can do quite a bit of manipulation. You can start doing things like accounts of events flowing through and things like that. So let me just stop that out of the way. Whilst that runs to its conclusion, let's just kill my Slack so it doesn't keep bleeping away. There it is. Great. If we come back here, so that's a very, very quick demo, and you can see how straightforward and simple it is to take file, transform it, filter out specific events, and then route it to different destinations. Okay, so if we carry on, I've talked about the distribution. I made a big point of talking about the challenges of distributed solutions. So here's just a few examples of how we can make this scale up. This is a traditional scaled out server setting where you've got multiple servers, and you might aggregate your logs to a more central node, which will then pull all the data into a analytics platform such as Elasticsearch or Splunk or something like that. And of course, doing the sort of thing I've just illustrated of filtering out specific events to say, actually, this is so important, I need to tell you now, not wait for the analytics platform to parse across all the events and go, aha, this is important. And of course, this could be adapted to be Kubernetes and in containers, and Kubernetes actually has the option to include Fluentd as a worker process, and you can either get all your containers to write to a shared location for logs, or you could deploy Fluentd's baby brother, Fluentd, which has got a very, very small footprint version of Fluentd into the container itself. That way you don't have to start expanding it and exposing all your logs to a central location. The pod just filters out the significant stuff and routes it to wherever you need it to go to. And of course, an alternative option is to use the sidecar pattern, which means that it's actually sits outside of the Docker image of your application, but it sits within the pod and can be used by multiple processes within that pod. Just to bring it home and bring it to reality, this is actually a real use case that we built recently for a customer. You can see on the left-hand side, we've got multiple origins, both on-prem and in cloud, using traditional applications and Docker logs, because standard practice says for Docker images, just write to standard out. It does have some downsides, but it's an option. And then we keep the tracing separate because we can use Jaeger to do a more comprehensive analytics on performance points, but we're also gathering up the log events, sending the security-based events to Splunk. We're exposing logs through Prometheus into Grafana. We're using Cassandra rather than Elasticsearch as a repository for more historical examination, and then trying to sort of mine back and look at other issues. And of course, we can generate Jira events for the really big issues. And that's that. And in just over 25 minutes, we've hit Fluentd in its basic flavor. So thank you very much. I don't see any questions pop up, so I will be on Slack to answer any questions that might come up in the meantime. If you want more information, then just take a note of these details here. You'll find this and an awful lot more in terms of information around Fluentd and modern apps-based technologies. Thank you very much.